Greetings! Today we are going to cover the topic polar forms of complex numbers. The polar form of a complex number is another way to represent a complex number. The question is that how do we change the rectangular form of complex numbers, z equals a plus b iota, into polar form? And what exactly polar form represents? In polar form, the complex numbers are represented as the combination of modulus and argument. The modulus of a complex number is also known absolute value. This polar form is represented with the help of polar coordinates of real and imaginary number. Polar form helps in showing the magnitude and the angle made by the vectors involved, helps in navigation and position purposes. It also makes operations on complex numbers easier. Conversion of rectangular form into polar form. The two things we need to calculate are absolute value / modulus. Principal argument of the complex number. The rectangular form of complex number is given as z equals x plus iota y. Let us consider x, y, are the coordinates of complex numbers x plus iota y. We can represent them in the Cartesian plane as finding the values of x and y. Do the formulas, sine theta equals perpendicular / hypotenuse, and cos theta equals base / hypotenuse, ring any bell to you? They do, right? Finding the values we get, sine theta equals y divided by r and cos theta equals x divided by y equals r sine theta and x equals r cos theta. Substituting the value of x and y in equation, z equals x plus iota y, we get z equals r cos theta plus iota r sine theta. Taking r as common, equation becomes z equals r cos theta plus iota sine theta. This is the equation for polar form of complex numbers. Let's go through an example to get a better idea. Z equals 1 plus iota. Let's start with calculating r, modulus of z. We know the formula, r equals x squared plus y squared. Here, x equals 1 and y equals 1. Equals greater than r equals minus 1 squared plus 1 squared. R equals 1 plus 1. Now, we are going to find the argument. In some part of our brain we have this formula stored. Tan theta equals y divided by x. Theta equals tan inverse y divided by x. Theta or argument of z equals tan inverse 1 divided by minus 1. Theta equals tan inverse minus 1. We know that, tan inverse minus 1 equals pi by 4. Theta equals pi by 4. Final step is to substitute the values of r and theta in equation, z equals r cos theta plus iota sine theta. Z equals under root 2, cosine pi by 4, plus iota sine pi by 4. The above can be written as z equals under root 2, cos pi by 4, iota sine pi by 4. R cos theta plus iota sin theta, and is often abbreviated as RCIS theta. So, our final answer is z equals under root 2 CIS, pi by 4. That's it for today. Thank you for watching.